It's an amazing thought that in the living world, no two things are the same. No two chestnuts, or acorns, or even leaves are ever exactly alike. Every flower on every plant, every leaf on every tree in every forest is different from every other. We humans do our best to tidy the world up, to make it neat and mathematical. But sooner or later, nature finds a way to mess things up again. At the Potsdam Institute for Climate Impact Research, hundreds of scientists work in buildings scattered through the woods, collecting data about how humans are affecting the climate and turning it into computer models that will show the rest of us how to avoid catastrophe. So as I met them, I asked them this question. How can the unimaginable complexity of nature, including all of us, possibly be reduced to models that fit onto a computer, however big, and are actually useful?
At the first look, when you start to realize this diversity, it seems like, yeah, why would one want to try, or even how can one even succeed in modeling and abstracting this incredible diversity into something that you can put into a computer?
Still, many theories are very boldly abstracting away all kinds of differences between, for example, gas particles, and economists try the same for people. The difference between a gas and a bunch of people is, while the particles in a gas are all basically the same, they're all identical, you could say, that's not true for people.
Clearly, you can't put the whole world into a model, because then the model would be the size of the whole world. So how to decide what to put in and what to leave out?
So one of our main struggles is actually to understand the diversity of the forest. So the balance is always to find the right way of expressing that diversity that really matters. So for example, we talked about the different shapes of leaves, and you see them, they're all different here everywhere. And what is important about their shape is that when they are at the top of the canopy, you have different leaves that at the bottom of the canopy, of the same tree, same species, same everything. Because if they are very high up, they get a lot of sunlight, which means they can be smaller and thicker, whereas if they are at the bottom of the canopy, they have to be large to recept as much sunlight as possible. And this kind of abstractions or simplifications are really crucial for our work, because well, otherwise we would get lost in the details, of course, which we like to do.
Yeah, people all think of models as something very abstract, mathematical, that researchers are doing, while in fact everybody of us is using models in their daily life. When he in the morning gets up and thinks about, for example, which clothes to wear. And then he combines information from different sources, like watching out of the window, thinking about the weather in the past days, thinking about the season they live in, and then they choose, for example, their clothes based on that, whether they wear a jacket or a t-shirt or short trousers. So you have another model which thinks about the attractiveness that you might have in respect to a specific person, which clothes they like about you. And yeah, you combine all of this to make decisions.
So why do we need more than one model? Models are always wrong, and they're always a simplification of reality. You can imagine traveling to a city, and you can actually compare our models to the maps of that city that you will be using. So you have one map, just the regular city map. Then you have one map that is only for pedestrians, that has the nice sort of sightseeings indicated and so on. And then you have one for bicycles and one for the underground. And of course, the map that represents the underground is a very different map than the one that is used for driving your car in the city. And that's why we are also comparing our models to understand what are these different layers that we want to bring together, just like you need all these different maps to have a pleasant day in the city where you can walk around, cycle and take the underground, and in the evening when you're tired to get back home.
But even with a map, people don't always want to go in the right direction.
We are trying to find out how the world is functioning, and these messages we want to convey to politicians in order to support them to take the right decisions. So first we started with simple climate models, just explaining on a planetary scale how the global warming is accelerating depending on greenhouse gas emissions. And then we sent this messages to the politicians, and they took it and said, okay, so it's fine, but when it is getting warmer, why not?
Yeah, how could you use models to really make a difference in the real world? That's of course a very hard thing. Take, for example, protesting for some cause, let's say climate change. Given that we already know that safely more than 50% of the world population are very concerned about climate change, these models can now tell us whether it's more important to start this protest wave by a very dispersed number of people, or whether it's more important to have them concentrated in certain places. And it turns out that it's actually a mixture of these. You need some initial concentration, some amount of people in the same place to get it starting in that place, but you also need many places so that it will cover the whole population eventually. So this is how these very theoretical models can actually help you to make decisions in the real world. They can't predict really numbers, but they can tell you which types of measures are more profitable, more promising than others.
Not everybody goes on protests, but everybody does eat, though what we don't eat can be more of a problem.
So in the moment we have a food surplus of 500 kilocalories per capita, and so per person and day. That's a huge amount. We have already 20% more food than we need. So just the surplus of food produces between 8 to 12% of the global carbon dioxide emissions.
This is one problem that seems easy to solve right now.
Today, many people are very disconnected from the food that they eat. They purchase the food in the supermarket, but they don't know how it is produced and how it connects to the environment or to their personal health. And school gardens or other public spaces where people grow food can be a very important measure to connect people back to where the food actually comes from.
And producing food locally has, as I said, has a lot of dimensions. So in Berlin we have a lot of these small markets in the different urban quarters. And when you have done your business, so buying your food, and then meeting friends there and talking a little bit, and this is a nice, it has a social dimension, so to say. Yeah? It's not only just buying food.
But remember that comment about gas particles being easier to model than people.
If you look at the most dominant or the most frequently used models that assess those changes at this kind of global level, there are actually no people there. And this bothers me, and I think it's a part of the problem why we cannot progress with certain issues, because we address people as sort of like some sort of averages.
So here we are, back to the original thought. No two living things are the same. And if it's hard to capture what's different between leaves, how much harder must it be to do the same for people, or even birds, each with their own agenda?
What I think a lot of people may not be aware of is that models are not so much an objective truth about where we are, where we're heading, or where we've been, but they come with a lot of assumptions. They have a lot of ideas baked into them about what humanity is, what economic system we have, what political things are feasible and not feasible. And social sciences can help modelers, which are often natural scientists, often atmospheric scientists or economists. They can help them reflect on those assumptions.
There's this debate in climate science that maybe we have too many people on Earth, but if you look at the inequalities, at least in CO2 emissions, it's actually not about the whole number of people, but it's about the number of the rich people. You could double the number of the poor people and it would make only a very small difference in terms of global CO2 emissions. But if you would double the number of the rich people, it would be a disaster.
Maybe our specific civilization, a sort of Western Enlightenment-inspired civilization, has often thought of itself as conquering nature, cultivating nature, dominating it, that we now need to sort of turn around and understand that some cultures are very good at taking care of their ecosystems and environments, and it's quite extractive industries and consumerist societies that cause most of the harm.
Maybe the answer is just to slow down and admit there's a lot we still don't know.
The forest is more than the sum of its parts, let's say. You have a kind of synchronization in a sense that all the beech trees in an area will all have their seeds ready at the same time. Yeah? So we call it masting events. Yeah? Every 5 to 7 years, they all synchronize to have their acorns being developed at the right moment in time, so that in this year there are so many that not all the wild boars and all the animals, so they cannot eat them all, but some will be left over and then germinate and grow into new beech trees. I think this is very, very mysterious, and it's showing us that it's much more than just an assemblage of individual trees that sort of live in isolation.
We are one of many species. We have a lot of co-critters on this planet, and we need to learn to diminish the impacts we have on the natural environment so that we can flourish together.
It's very important that we have these spaces to just go to and to just being reminded that there is something out there that is still growing and sort of developing according to some principles that we don't even fully understand.
So I found out why models are useful and what their limitations are. But that begs another question. How can they know so much and yet not lose hope?
I try to change the things that I have influence on through teaching. What I kind of try to maintain is that they are kind of thinking critically, that they are asking questions and they are not afraid to criticize me or someone else. And we need young people to kind of to show this kind of radicality and show that different lifestyles, different choices are possible.
What do we want? When do we want it?
What I also think is that humanity was always creative enough in the past to develop solutions to cope with this. And this forces me also in my daily work, of course, or pushes me in my daily work.
Being able to work on the subject is actually relieving me to some extent from that kind of pressure to do more in my personal life, although I, of course, think I should be doing more. And actually, if you compare it with everybody I know, we are always being accused of doing too much. Yeah.
I try to go for walks with my children and show them nature and interact with nature. But sometimes, of course, they don't want to do such things, or they prefer to stay at home and watch TV. So sometimes I'm helpless.
Researchers react very differently to it. Some are very discouraged about it. I see it more like a challenge and also something that gives my life a certain meaning to fight against these problems and to find a solution.
So sometimes when you study climate change and related things, then you might get a little bit depressed about this. And I like to walk through the garden and look at nature and see how nature always copes in a sense. So that gives me a lot of hope that even if humanity kind of fucks up, nature will probably survive us. Is that positive? I'm not sure. It's as positive as I can get, I guess.
Sorry, I was not sure whether I did what you wanted.
Okay, I got it.
Do you think you've said most of the things you want to say?
I think so, yeah.
Plus you want to get away and see your brother.
I'm not prepared for this question.